All right, so this is 3.3/3.4. So first thing we're going to do is look at our change of base using common logarithms. So earlier this week I told you that we can't compute a log when it has, at least we can't compute it in our calculator when it has a base that's not 10. So our calculator can do, bless you, log base 10 of some number. Some people's calculators can change the base, but now we're going to find out how we can put it in the calculator when we have a different base. So what we would do is take the log of the big number over the log of the little number. So in our calculator, we would do log 25 over log 4, or divided by log 4. If you're doing this in the calculator, make sure you put this in parentheses and this in parentheses if you want to do it all in one step. 2.32. So looking at B, we would do the same thing. The bigger number goes on top, so log of 12 over log of 2. And just divide. 3.58. We can also change the base using the natural log. So instead of doing log of 25 over log of 4, we could also do ln of 25 over ln of 4, and we get the same answer. So instead of doing logs, you just do ln's, and it's the same thing. So what do you get for ln of 25 over ln of 4? 2.32. Same thing that we got in A here. And then what about for B? If we did ln of 12 over ln of 2. Same thing, 3.58. Awesome. So it works either way. You can do logs or you can do ln's. So that's our change of base formula. All right, next we're going to look at properties of logarithms. So this is our expanding and condensing logs. So when we have two things being multiplied inside the parentheses here, we can expand it into log base A, so the base stays the same, of u plus log base A of b. So when you expand it, every time you break it up, each thing gets its own log. And then multiplication goes with addition. So when you're expanding it, you break multiplication up using addition. We can also condense it. If we have two logs that we're adding together, we can go the opposite way and combine them into one log just by multiplying them. So multiplication goes with addition. Similarly, division goes with subtraction. So if we had the log base A of u divided by v, this would be log base A of u minus log base A of v when we're expanding. So we can expand it into two logs by using subtraction. So subtraction goes with division. The one on top goes first, so the order does matter. The one on top goes first, the one on the bottom goes behind the minus. In our power property, if we have an exponent on what we're taking the log of, that exponent can move to the front of our log when expanding. So it's just being multiplied out front.
So will the directions be to expand?
We're going to skip example 3 and go to the next page. So all of these apply to logs, but they also apply to natural logs too. So you can just replace the log with the ln, and it's the same properties. So you won't have to know example 3.
So they kind of forgot like the.
All right, so for A, here we have to expand the log. So what are we doing between 5x cubed and y? What's happening here? Multiplication. So how do I expand when I have multiplication? You add them. And every time you break it up, each thing gets its own log. So I have log base 4 of 5 plus log base 4 of x cubed plus log base 4 of y. And then I want to move this x cubed, the cubed, to the front of that log. So here I would have log base 4 of 5 plus 3 log base 4 of x plus log base 4 of y. So when you're expanding, you shouldn't have any exponents. All of those get moved to the front.
What did you do with this?
All right, so let's look at B. So I want to treat the top as one thing and then the bottom as another. So since I'm dividing, how do I expand when I'm doing division? Subtraction. So I'd have ln of square root 3x minus 5 minus ln of 7. I have a square root. What exponent is a square root? 1/2. So this is ln of 3x minus 5 to the 1/2 power. And then when expanding, what can I do with an exponent? Put it to the front. So this would be 1/2 ln of 3x minus 5 minus ln of 7.
Wait, why did you do that?
And then here, since these are in parentheses, and it's 3x minus 5, you're not multiplying or dividing, you can't break it up. So if it was just 3x, we could break it up because that's multiplication. We know we can break up multiplication into addition. But here, since we have 3x minus 5, you can't split it up. So this would be our answer. Any questions there? Okay, example 6. Here we are condensing. So looking at A. First thing I want to do is move my exponents that I'm multiplying up top. So the reverse of what I did before. So I have log base 10 of x to the 1/2 power plus log base 10 of x plus 1 to the 3rd power. Now I'm adding, so how do I condense when I'm adding? Multiply. So when you condense, we get rid of one of the logs, so we're only going to have one log. So log of x to the 1/2 power times x plus 1 cubed. This would all go in parentheses because it's the log of all of that. All right, so looking at B. What should I do first? Bring the 2 up top, so I have ln of x plus 2 squared minus ln of x. What should I do next? I'm subtracting, so to condense it, I'm going to divide. So ln of x plus 2 squared divided by x. And that's my answer. Okay, and then for C. So I want to do inside the parentheses first, and then I'll worry about the outside at the end. So how can I condense what's inside? So I'm adding, so that means I'm going to multiply, so I get rid of one of the logs. So I have log base 2 of x times x minus 4. I'm going to distribute this x just because the x minus 4 doesn't have an exponent on it. So this is log base 2 of x squared minus 4x. And I have that 1/3 outside. What can I do with that 1/3? No. It's being multiplied out front, so I bring it to the top. That's the exponent. So log base 2 of x squared minus 4x to the 1/3 power.
And you would have to
You could, which on WebAssign, I don't know if it would take the 1/3 power or the cubed root, but your homework tonight's not going to be on WebAssign. There is a WebAssign for 3.3/3.4, but it's just extra practice. So if you notice on Canvas, there's nowhere to turn it in. It's because you don't have homework on WebAssign tonight.
And then if we didn't distribute the x, is that points off because we didn't distribute the x in A, but it also wouldn't have a power. So is that why we didn't?
Yeah, that's why we didn't in A, because we would have to cube this first before we distributed the x.
Okay.
Any other questions here? Right, next page. So, example 1, the first 4 properties here we did yesterday. These are 1-to-1 properties. So looking at, for A, if your bases are the same, you can cancel them out and just set the exponents equal to each other. If you have a log equal to a log, you can cancel them out. Set what they are, the logs of them equal to each other. Same with the ln's, they cancel. Here, same with the 3's, they would cancel. Now we're going to look at some new properties. So these are inverse properties. So E through H are new. These are going to help you solve when you have e's, ln's, and logs in your equation. So if you have e to the power of x is equal to 7, one way that we can get that x out of our exponent is by taking the ln of both sides. Because what we do on one side of the equation, we have to do to the other. And what's ln of e? 1. So this would cancel, and the x being our exponent just moves to the front. So it would be like x times 1, which is just x. So x is equal to ln of 7. And then we would have to use our calculator to find out what ln of 7 is.
1.95.
When you have the ln of x, we make our base e, and the rest of the equation are exponents. So this is e to the power of ln of x, and e to the power of -3. So e to the power of ln cancels, and we're just left with x is equal to e to the power of -3. And then we could just put e to the power of -3 in our calculator.
Wait, why did you put the e there?
Because I'm doing the inverse of ln to help me solve for x. That's what all of these are, properties to help you solve for x.
The inverse of ln is e?
E. Because e to the power of ln is 1, it cancels out, and the ln of e is 1, so it cancels out.
Okay.
And then we can do it with logs also, but we would just take whatever our base is. So here we have log base 10, and this would be 10 to the power of log base 10 of x. And what we do on one side, we have to do the other, so it'd be 10 to the power of -1.
So anything to make it 1.
Anything to make it 1 to just cancel it out. So this would be x is equal to 10 to the power of -1.
So put to the same power as the base?
Yep. So for h, same thing, put to the same power as or put your big base as the same power as the little base. So this would be 3 to the power of log base 3 of x, and 3 to the power of 4. So this cancels, so you'll get x is equal to 3 to the power of 4. All right, so let's apply these in our examples. So looking at A, how can I get that x from out of my exponent? So I'm going to multiply both, or take the ln of both sides. So I have the ln of e to the power of x is equal to ln of 72. So ln of e cancels, so I have x is equal to ln of 72. And we can just take the ln of 72 in our calculator. So what's ln of 72? 4.3. All right, for B, what do you think I should do first?
Divide by 3.
Awesome, divide by 3. So anytime you have something funny like x in the exponent and e and ln, you want to isolate that. So then we can use one of our rules. So here I want to divide the 3 on both sides. So it'll cancel. So I have 2x is equal to 42 divided by 3. 14. And then what should I do?
Make the base 2 for the 14. Oh, no.
If we add the e, it wouldn't really do anything because e here wouldn't cancel it out. But if I took the log base 2 of both sides, so log base 2, this cancels. But I would have to do it on this side also, log base 2. So this would be x is equal to log base 2 of 14. And then how can I put log base 2 of 14 in my calculator?
You do log 2 over log 14 over log 2.
Log 14 over log 2. The bigger number always goes on top. So I always just think about it as like putting a line, like the one that's already higher stays on top. So then what's log of 14 divided by log of 2? 3.8. So that's our answer. All right, so here. Again, I want to try to isolate that number with the exponent, or here in this case, the e with the exponent. So what should I do first? Add the 3. So I have 4e to the power of 2x is equal to 5. What should I do next? Divide by 4. So e to the power of 2x is equal to 5/4. Then I take the ln of both sides. Because what's the ln of e? 1, it cancels. So then 2x is equal to the ln of 5 over 4. If you take the ln of 5 over 4 in your calculator, make sure you put 5 over 4 in parentheses. Because if you didn't use parentheses, it would just do the ln of 5, then divide that answer by 4. So make sure you do the ln of 5/4 in parentheses.
And then we divide that by 2.
And then we'll divide it by 2. So what do you get when you take the ln of 5/4? 0.22. So then we divide both sides by 2. So what's x equal to? 0.11. All right, let's look at example 4. What should I do first? Before I do that, add 4. So 2 times 3 to the power of 2t minus 5 is equal to 15. Then what should I do? Divide the 2. So 3 to the power of 2t minus 5 is equal to 15 divided by 2, which I'll say 7.5. And how can I get that t from out of the exponent? I can do log base 3 on both sides, because the log base 3 of 3 cancels. So I have 2t minus 5 is equal to log base 3 of 7.5. How do I find what log base 3 of 7.5 is? Awesome. Log of 7.5 divided by log of 3. So what do you get when you put this into your calculator? 1.8? Yes. Awesome. 2t minus 5 is equal to 1.8. What should I do next to solve for t? Add 5. So here it's just basic. We know how to solve for t. So 6.8, then divide by 2. So what's t equal to? 3.4. All right, let's look at A. So again, here we are solving. So I have ln of 3x is equal to 2. How do I get rid of that ln? Make a big base of e. Because e to the power of ln cancels. So I'm left with 3x is equal to e squared. So I could put e squared in my calculator and then just divide it by 3. So then what's x equal to? 2.5? After you divide. So 2.5. I divided it because it was 3x. So I divided 3 on both sides. Alright, so for this one, if I have log base 3 of 5x minus 1 is equal to log base 3 of x plus 7, what happens? The logs cancel out. Awesome. So 5x minus 1 is equal to x plus 7. How do I solve for x? Like normal. I can subtract x on both sides, so 4x minus 1 is equal to 7. Add 1 to both sides, so 4x is equal to 8. Divide by 4. What's x equal to? 2. Alright, let's look at example 7. So how can I solve for x? What should I do first? Subtract 5 on both sides, so 2 ln x is equal to negative 1. Then what should I do? Divide by 2. So ln of x is equal to negative 1/2. Make the big base e. So this will cancel. So x is equal to e to the power of negative 1/2. Then I can just put that into my calculator. What do you get? What'd you get? 0.6. Technically, this would be,
e squared, or as the denominator.
it would be 1 over e to the power of 1/2,
Yeah.
which also is 1 over e, the square root of e. But these are just like the same thing, they just look different. But you're putting it in the calculator, so you don't really need to make it look different because you're just putting it in the calculator. So example 8, what should I do first? Divide by 2. So log base 5 of 3x is equal to 2. And how can I get rid of that log? Make the big base 5. So this cancels, so 3x is equal to 5 squared. So 3x is equal to 25. And then what can I do? Divide by 3, divide by 3. So x is equal to 8.3. Alright, let's take a look at example 9. So I have 2 ln's on one side. What can I do to combine it to 1 ln? Use multiplication and drop the ln. So this is ln of x minus 2 times 2x minus 3. And then I also want to move this 2 just so I have like a clean ln on that side. So what can I do with it? But then I'd have a divided by 2 on the other side. I want it to be ln of something is equal to ln of something. Yeah. So what can I do with it?
Can you put it on the x? Don't you put it to the 2?
I put it on the x. So this would be ln of x squared. So now that I have ln of something is equal to ln of something, what happens? Well, they just cancel. Because when ln's on both sides, they cancel. So here I have x minus 2 times 2x minus 3 is equal to x squared. What should I do next? What? FOIL. So x times 2x is 2x squared. X times negative 3 is negative 3x. Negative 2 times 2x is negative 4x. Negative 2 times negative 3 is 6. What should I do next? Subtract x squared on both sides. So this would be x squared minus 3x. Well, combine my like terms here. So this would be minus 7x plus 6 is equal to 0. Then what can I do to solve? Factor. So what are two factors of 6 that add to negative 7? Negative 6 and negative 1. So x minus 6, x minus 1 is equal to 0. Solve the same way I would before. So x minus 6 is equal to 0. X minus 1 is equal to 0. So x is equal to 6 and x is equal to 1. For this one, since we got two answers, we have to check for extraneous solutions. You cannot take the log or the ln of a negative number. A negative number, not possible. Can't do it. If you tried to do it in your calculator, it wouldn't work. So what I want to do is plug 6 into all the ln's here. So here, here, and here. And see if it gives me a negative number. Because then I'd be taking the ln of a negative, and you can't do that. So you have to check both. Then we'll check 1 next. But if we plug in 6, I have x, or 6 minus 2, which is 4. So that's positive. And then I would have 2 times 6 minus 3, which is 9. So that's positive. So 6 works. Now let's check 1. What's 1 minus 2? Negative 1. Can't take the ln of a negative, so 1 does not work. That is not one of our answers. It's an extraneous solution.